Thank you, Jerry. Add my welcome to all of you this morning. I know for some it's been a challenge to get here, but we really appreciate that. Rotary is directly governed by 500 local district governors all over the world. And our local district governor is Christina Doherty. Governor Doherty could not be with us today due to other Rotary business, but she has sent this welcome to you. Welcome. I am Christina Doherty, District Governor of District 6540, which is in the northern section of our state of Indiana. We have looked forward to you being here today for this World Affairs Conference. For many years, Rotary International has sponsored a conference for high school students to learn and to discuss a current topic of world interest. This year, the topic is the storm over climate change, policy and politics. Today, presenting are two keynote speakers who will discuss climate change from opposing viewpoints. They are Jorge Ortiz from the Office of Senator Joe Donnelly and Steve Gorham, the Executive Director of the Climate Science Coalition of America. Rotary is an international organization which began in 1905 in Chicago and now has over 1.2 million members in 34,500 clubs in 168 countries around the world. You may have a Rotary Interact Club in your school, which is a Rotary-sponsored organization for high school students that provides support for local and international service projects and to have fun being together. Joining a Rotary Interact Club provides an opportunity to get to know your community and to support programs locally and internationally. For high school students, there is also a student exchange program to foreign countries, weekend leadership training, and a district speech contest. These are some of the programs that Rotary offers for undergraduate students, for high school students. We hope you'll take full advantage of today's opportunities to learn and join in the discussion, and thank you for being here today. Today's first speaker is Mr. Steve Gorham. Mr. Gorham is the Executive Director of the Climate Science Coalition of America, a non-political association of scientists, engineers, and energy experts whose mission is to educate Americans about the realities of climate science and energy economics. He has authored 2 books on climate change, Climatism, Science, Common Sense, and the 21st Century's Hottest Topic, and his latest book, The Mad, Mad, Mad World of Climatism, Mankind and Climate Change Mania, with now more than 100,000 copies in print. And there, you saw on the registration table, we have free copies of that book for each one of you. Mr. Gorham is a frequently invited guest on radio and TV, a freelance journalist, a former engineer and business executive, and a resident of New Lenox, Illinois. He holds a master's degree in electrical engineering from the University of Illinois and an MBA from the University of Chicago. He wants us to tell you that he has never received payment from any energy company or any organization with a vested interest in the global warming debate. Please welcome Steve Gorham.
Well, thank you, Jim. Good morning, students. Great to join you today. My hat's off to the Rotary and the University of Manchester for sponsoring this great event. We're having quite a winter, aren't we? Winter of 2014. Great picture here of the Great Lakes frozen over with ice. We're having a good old-fashioned North American winter. And here's a picture of Niagara Falls a few weeks ago, frozen over. That's the Canadian Horseshoe side. Pretty amazing. But some say that the snow is disappearing. David Archer and Stefan Ramsdorf, in their book, The Climate Crisis, just a few years ago, one of the robust findings of the report, and they're referring to the Intergovernmental Panel on Climate Change report of 2007, is that snow cover in most continental areas will dramatically decrease unless warming is stopped. Large areas are expected to become snow-free. Funny thing, though, North American snow extent has been increasing. According to data from the Rutgers University Global Snow Lab, we've been on about a 40-year trend of increasing snow extent. This is just one area where empirical data is out of step with the theory of man-made warming.
We have arrived at a moment of decision. Our home, Earth, is in danger. What is at risk of being destroyed is not the planet itself, of course, but the conditions that have made it hospitable for human beings.
And we know the facts. There's not any more debate, is there global warming or not. We have global warming, and the fact also is that we can do something about it.
Well, former Vice President Gore and former Governor Schwarzenegger are in good company. Today, more than 190 heads of state of the nations of the earth have accepted the theory of man-made warming. The United Nations, most of our scientific organizations, most of the news media, most Fortune 500 companies, most universities have all signed up to the idea that mankind is causing dangerous climate change. And the world is spending over $250 billion a year to try and keep the planet from warming. Let's look a little bit at the basis for the theory of man-made climate change. And the theory is based on 4 principles. The first is rising global temperatures. We've had about a 1-degree rise in temperature since the Civil War. Second, rising atmospheric carbon dioxide levels. Levels were first measured in the 1950s. At that time, scientists measured about 315 parts per million in our atmosphere. Today, the levels are up to about 400 parts per million. The proponents of the theory of man-made warming say this is what's causing our global temperatures to rise. Third is the greenhouse effect. Sunlight enters our atmosphere. It's absorbed by the surface of the Earth. Like any warm body, the Earth gives off lower energy infrared radiation. A little bit of that goes out into space, but most is captured by greenhouse gases in our atmosphere. Those greenhouse gases then re-radiate that energy, and that does tend to warm the surface of the planet. The theory says that emissions from man-made industries add to the greenhouse effect and raise global temperatures. And the fourth basis is computer model projections. Supercomputers like this one in England predict a much faster rise in global temperatures. We've had about a 1-degree temperature over the last 130 years or so. The models predict a 3 degrees Celsius or 5.4 degrees Fahrenheit temperature rise on average by the year 2100. And from that, you've all heard about the disasters that are proclaimed: melting ice caps, raising our oceans, flooding our coastal cities, stronger hurricanes and storms, droughts and floods, and species extinction. But students, members of the Rotary, members of Manchester University, there is no solid empirical evidence that increasing greenhouse gases are the primary cause of global warming. Earth's climate is complex. It's a powerful interplay of forces from our solar system, our atmosphere, our oceans, and our land. This is just a simplified diagram. Sun falls directly on the equator and the tropical regions where much energy is absorbed. It falls indirectly on the polar regions. All weather on Earth is driven by this energy difference. Storm fronts, ocean currents, jet streams, microbursts, hurricanes, all distribute energy from the tropics to the poles. The oceans have a powerful effect on Earth's climates. The oceans can hold the oceans have 250 times the mass of the atmosphere, and they can hold more than 1,000 times the heat. And then we have aerosols coming out of the biosphere in the ocean, dust from volcanoes, pollen from plants, desert dust, man-made emissions. All of those go to shape the climate. Yet today's climate scientists are obsessed on the level of carbon dioxide in the atmosphere, a very small part of the overall picture. Matter of fact, carbon dioxide is a trace gas. One way to picture it is to picture a look at a basketball arena. Here's Duke Cameron Arena after Duke won the National Collegiate Championship in 2010. Picture 10,000 students, compare those to 10,000 molecules in the atmosphere. Only 4 of every 10,000 molecules in our atmosphere are carbon dioxide. And the amount that mankind could have added in all of human history is only a fraction of one of those 10,000 molecules. I'm going to pose a question for you. Maybe you've learned this in your science class. What's nature's most abundant greenhouse gas? Anyone? Everybody's timid today. It's not carbon dioxide. It's not methane. The answer is water vapor. Earth's most abundant greenhouse gas is water vapor. Scientists estimate that somewhere between 75 and 90% of Earth's greenhouse effect is due to water vapor in clouds. If we're conservative and we say 75%, then the last quarter of Earth's greenhouse effect is due to carbon dioxide, methane, and other gases. But then we need to ask, well, how much of this last quarter of the greenhouse effect is due to man-made emissions? Because the oceans contain 50 times as much carbon dioxide dissolved as is in the atmosphere. And the oceans are always releasing carbon dioxide and absorbing it. When plants grow, they absorb carbon dioxide. When they die, carbon dioxide is released. And then we have volcanoes both above the surface of the ocean and about 10 times as much under the surface of the ocean, 10 times as many, putting gases like carbon dioxide into the environment all the time. It turns out that of this last quarter, nature releases 25 times as much carbon dioxide into the atmosphere as man-made industries every single day. That means if you put this all together, that means the man-made portion of the greenhouse effect is about 1 part in 100. Who's heard that in the news? Nobody. We all hear how we're putting greenhouse gases in the atmosphere, we're causing the greenhouse effect. But when you break it down, mankind's responsible for only about 1% of the greenhouse effect. That means if we completely eliminated all emissions, we probably could not measure the difference in global temperatures. Now, if movie detective Dirty Harry was a climate scientist, he'd probably say, your climate models ain't making it. Indeed, for the last 17 years now, we've had flat global temperatures. You can see the 2 lines here, the red and blue lines. Those are data from satellites. No global temperature increase since 1997, even though atmospheric carbon dioxide has risen about 7%. All 44 of the world's climate models are shown here, all these spaghetti graphs, and the average is this black line. They've all predicted a rise in global temperatures over the last 17 years, and we haven't seen that. So all of the climate models are in error. Now, you've probably heard that the Arctic ice is melting, the glaciers in Glacier National Park are melting, the snows of Kilimanjaro are disappearing. The important thing to remember is that melting is evidence of warming, but does not tell you the cause of the warming. You probably also heard climate change is real. Who's heard that one? Everybody, of course. Well, that's a true statement, but it's about as profound as saying water is wet or grass is green. Of course, climate change is real. Global warming is real. Global cooling is real. Climate change is not only real, it's continuous. It's been happening for all of Earth's history. 2 well-known periods of climate change are the medieval warm period and the Little Ice Age. The medieval warm period is a warm period from about 900 to 1300 AD, when the Vikings settled southwest Greenland. They founded a colony at Helvasi 600 years before the Jamestown colony. They farmed, they raised livestock, they hunted polar bears and traded the skins. The Book of Icelanders, a historical book, says that at the time there were trees 6 meters high at Helvasi. This is a picture of the old stone church at Helvasi today. All there is in the location are scrub grasses. It was warmer 1,000 years ago than it is today. About 1300, the climate cooled as we entered the era of the Little Ice Age. Not a true ice age, but about 1 to 2 degrees Celsius cooler than either the medieval warm period or our modern warming today. Very tough time in Europe, famine, shorter growing seasons. The population of Iceland decreased by about 50%. But they used to hold a thing at London called the Frost Fair, a festival every year. The Thames River would freeze solid at London. Here's an image. They'd bring their horses and wagons right out on the river, build sheds, have fires, have this festival. Well, you can't do that today. The Thames River hasn't frozen solid at London for more than a century. So these are two natural periods of climatic change, warm and cold, nothing to do with man-made greenhouse gas emissions, and these sorts of periods have been going on for a long, long time. If we look at a little more quantitative example, using ice core proxy data from Greenland, we start here at 0 present day, go back 2, 4, 6, 8, 10,000 years to the end of the last ice age, and we see the temperature rise and fall and rise. Here's the Roman climate optimum 2,000 years ago when the Roman soldiers wore those little skirts. At that time, they harvested olives in Germany, and they harvested wine commercially, grapes for wine, in England. Here's the medieval warm period, here's the little ice age, and here's our modern warm period. By the way, where would we be if we were in this very spot 20,000 years ago? Under a couple thousand feet of ice. Now, what you may have heard, even from our own U.S. government, is that the decade from 2000 to 2009 is the hottest on record. And recently they announced that January of this winter was globally the 4th warmest January on record. Those are true statements, but they are misleading. On record refers to the thermometer record. I'm going to show you how long that is. That's only 130 years long. See that little green dot right there? That's the on record, warmest on record decade. That ignores all of the temperature history and the warmer periods than we've had in the past that all occurred naturally. Here's an interesting picture of a white spruce stump located in the Northwest Territory of Canada, north of the Arctic Circle, up by Alaska. It's a very old stump. It's been radiocarbon dated to be 5,000 years old. But the interesting thing from a climate point of view is that it's located 100 kilometers north of the tree line. 100 kilometers north of any white spruce tree today, indicating that it was warmer 5,000 years ago than it is today. So climate change is natural. Global warming is caused by cycles driven by the sun. Don't have time to go into that today. It is in the book, though. And man-made greenhouse gases only play a small role. Now, we all want clean air and water, don't we? I'm old enough to remember when our air wasn't so clean. When I was young and we had a station wagon, I'm not sure you know what one of those is. We drove by Gary steel mills, and we had a brown film cover our windows. We had to pull over on the side and wipe it off. Or the time when we were driving into Los Angeles from the Mojave Desert, and we saw the smog rolling up the valley. But our air is very much cleaner today. Matter of fact, data from our Environmental Protection Agency, this bottom line is a line showing our 6 major air pollutants. 2009, 2012, now it's down to about 67% from 1980. That's carbon monoxide, nitrous oxides, sulfur oxides, lead, ozone, and carbon particulates. At the same time, we're driving twice the vehicle miles. We're getting 30% more electricity from coal. But some have decided that carbon dioxide is a pollutant, even though it doesn't hurt anybody physically. The news media and our Environmental Protection Agency. Students and ladies and gentlemen, that is bizarre. Carbon dioxide is not a pollutant. It's an odorless, colorless, invisible gas. It does not cause smoke, does not cause smog. What you see rising from this cooling tower is condensing water vapor. You can't see carbon dioxide. We breathe in only a trace of carbon dioxide with each breath, but we burn sugars in our body and produce carbon dioxide, and so we breathe out 100 times what's in the atmosphere with every breath. Now, next time you sit down for your meal at your dorm or in your cafeteria, and you see the sandwich and the salad and the fruit and the dessert and the beer, probably not beer at the cafeteria, but the soft drink, remember that every one of those things on your table requires carbon dioxide to be there. So if anybody here thinks carbon dioxide is still a pollutant, I want you to have the special meal from now on. That's water and salt. Matter of fact, CO2 is green. Carbon dioxide is plant food, essential for life on Earth. Hundreds of peer-reviewed studies show that increased atmospheric levels of carbon dioxide increases plant growth. Wheat, oranges, orange trees, young pine trees, even poison ivy grows bigger and faster with higher levels of atmospheric carbon dioxide. Plants get bigger root systems. They get bigger fruits, bigger vegetables. They get thicker tree trunks. They're more resistant to drought with higher levels of atmospheric carbon dioxide. If there's one compound we could put into the atmosphere that would be great for the biosphere, carbon dioxide would be that compound. Yet today we have every university trying to reduce their carbon footprint, every company doing the same. Is the science settled? Former Vice President Gore says, "The debate among scientists is over. We face a planetary emergency." There is no more scientific debate among serious people who've looked at the science. But most scientists will tell you that the science is never settled. Matter of fact, Albert Einstein said, "No amount of experimentation can ever prove me right. A single experiment can prove me wrong." What I hold here is a copy of the Global Warming Petition, created in 2007 by the Oregon Institute of Science and Technology. There's a little climate science in the front, but then it contains the names of 31,000 United States scientists, 9,000 PhDs, and I'm going to read you the second half of their statement that they signed up to. "There is no convincing scientific evidence that human release of carbon dioxide, methane, or other greenhouse gases is causing, or will in the foreseeable future, cause catastrophic heating of the Earth's atmosphere and disruption of Earth's climate. Moreover, there is substantial scientific evidence that increases in atmospheric carbon dioxide produce many beneficial effects upon the natural plant and animal environments of the Earth." So careful when somebody's telling you 97% of the scientists or that the science is settled. But what about sea level rise? Scientists have said, some have predicted a 20-foot ocean level rise by the year 2100. If that were the case, it would be a disaster. You could see all these areas in Florida, these red areas that would be flooded with a 6-meter rise. Well, to consider that, we need to talk about Earth's ice caps a little bit. It is true that Arctic ice has been declining for the last 30 years. This graph is from satellite data, and it reached a 30-year minimum in 2007 and again in 2013. 3 things you need to know about Arctic ice. First, Arctic ice comes and goes. There have been periods in the past when it has been low as well. Second, Arctic ice is floating on the Arctic Ocean. If it completely melts, it won't raise ocean levels at all. You can do an experiment with a glass full of ice and water at home, measure before and after it melts, and you'll see that floating ice doesn't change the level of water when it melts. Now, some scientists say that this is the canary in the coal mine. This is an indication that a trace gas in our atmosphere is causing catastrophic warming. But the third thing you need to know is that this is only 1 to 2% of Earth's ice, Antarctic ice, 1 to 2%. So we need to ask about the rest of the ice. And not 3 weeks after we hit a 30-year low in Antarctic ice, we reached a 30-year high in South Pole ice. Who's heard that in the press? South Pole ice is expanding. There's one guy. It's not reported very often. Antarctic ice has been on a 30-year rise, and this confounds the climate models. This is 90% of Earth's ice. It's been getting thicker, getting broader. Here's an interesting picture of the Amundsen Scott South Pole Station. The United States has maintained a continuous presence at the South Pole now for 60 years. This is the 3rd station that we've had down there. So here's my second question for the day. What happened to the previous 2 stations? Can anybody guess? They were covered by snow. That's pretty close. Because Antarctica is a desert at the South Pole, but every year they get about 8 net inches of snow. Next year 8 inches, next year 8 inches, next year 8 inches. Gets to be a problem. You can see the second station right over here, and there's snow all around it now. So they built this one, and they built it in 7 modules. And as you can see, the modules sit on stilts. So what they can do is they can jack up each module over accumulating snow, and prolong the life of the station. Folks, this is the South Pole ice, 90% of Earth's ice, and it's getting thicker. Don't have time for Greenland today, but the summary on Greenland is it's melting near the edges, but it is getting thicker in the center. So what does this mean for ocean rise? According to NASA, our oceans have risen 390 feet in the last 20,000 years. No scientist can tell you when natural ocean rise stopped and man-made ocean rise began. But over the last 150 years, our sea levels have been rising at about 7 or 8 inches per century. So there's good news and bad news about this. The good news is it's unlikely we're going to see a 20-foot rise by the year 2100. The bad news is that water ski Manhattan postcards are not going to be in big demand. But aren't natural disasters evidence of man-made climate change? You all remember Hurricane Sandy, 2012? Very special storm. Here it is, you can see the eastern seaboard here. Heading out in the North Atlantic, ran into a high-pressure area, bounced off of that, came in and made a direct hit on New York City. At the same time, it hit a storm front coming from the west, and it hit at high tide, creating a disaster and much flooding. Senator Bernie Sanders has said, Hurricane Sandy is a wake-up call for all Americans, that we must reverse global warming. It is increasingly clear that global warming is fueling more extreme weather disturbances. But this has happened before. Over the last 80 years, after the last, 300 years, 80 tropical or subtropical storms have struck the state of New York. An example is the Norfolk and Long Island hurricane of 1821. Coming right up the eastern seaboard, struck New Jersey. It was a Category 3 or 4 hurricane, much stronger than Category 1 Sandy. And it flooded Manhattan Island, a third of Manhattan Island up to Canal Street, even though it hit at low tide where the oceans were 5 foot lower. Over the 20th century, we've had 170 hurricanes make landfall in the United States. 59 of those were Category 3 plus hurricanes, stronger than Hurricane Sandy. So how is it then that a single hurricane that strikes New York City now becomes evidence of man-made climate change? If we look at global storm data, scientists now can look down and measure the wind speed of every tropical storm on Earth for every hour of its existence. And they put together a metric called accumulated cyclone energy. In 2005, when Hurricane Katrina hit New Orleans, there was an outcry that maybe this was due to man-made warming. But recently, scientists were able to report that we're at about a 30-year low in tropical storm activity. So there is no trend to increasing intensity or frequency of storms across the world. Matter of fact, it's now been 3,000 days since a Category 3 hurricane has struck the United States. That's almost 8 years. Typically, a Category 3 hits the United States shoreline every other year. We've not had an 8-year period without a Category 3 hitting the U.S. since before 1900. If we look at tornadoes, similar sort of thing. The count of strong to violent tornadoes, 1960s and 70s, we had more. If anything, we have less severe tornadoes over the last few years. Are the polar bears endangered? I mentioned that to some student earlier today, and they thought, oh yeah, the polar bears are endangered. Now, maybe you remember this guy. 2 or 3 years ago, we had a Super Bowl commercial with the polar bear trying to catch the Coke bottle, was able to do that. Every year, the World Wildlife Fund and Coca-Cola get together and run an Arctic Home campaign, raising money from all over the world to save the bear. And we probably have children all over this great nation breaking into their piggy banks and shipping money to Coca-Cola or the World Wildlife Fund. But in fact, number of bears have been increasing. Back in the 1960s, we had 8,000 to 10,000 bears on planet Earth. Today, we have 22 to 25,000. There is no evidence that the polar bears are endangered or that they are declining. Let's move on to climate, energy, and public policy. Enough science. Energy is a driver of global prosperity. If you put per capita, per person income on the vertical axis, per person energy use by nation on the horizontal axis, you see that the nations that use a lot of energy effectively have high levels of income, high economic levels for their citizens. The nations that don't are on the lower end. Now, all of the major nations of the world, the developed nations, have signed up to an 80% emissions cut by the year 2050. And the Obama administration has proposed an 83% emissions cut from the 2005 level of 5.4 tons of carbon per person. That's our average emission. That comes from our vehicles, our heating, our food, our agriculture, our industry. By the way, one thing I think I forgot to mention, or maybe I did, remember that this number is naturally 25 times the amount of human emissions comes from nature, goes into the atmosphere every day. Anyway, if we go back to the 1960s when we had televisions in every home, jet aircraft in our airlines, we were still at about 4.5 tons of carbon. We go back to the 1920s, washing machines were all the rage, and automobiles, we were at 4 tons of carbon. Go back to the turn of the century, the first light bulbs and electricity, we were still at 2 tons of carbon emitted per person. Turns out we have to go all the way back to 1870 to the emissions level to meet this goal. Now, to give you a comparison, the nation of Nigeria today puts out about 0.7 tons of carbon. Actually, we're talking carbon dioxide, but measuring in terms of carbon. 0.7 tons of carbon per person. There are only 3 cars for every 100 people in Nigeria, and about half of Nigerians don't have access to electricity. There is no world leader on earth who knows how to get this level of emissions from a developed nation without destroying the nation's economy. But some say that renewable energy is the answer. Repowering America with 100% of its electricity from clean energy sources within 10 years. Or here's this headline from the Wall Street Journal, 1978. Solar power seen meeting 20% of needs by 2000. But this is energy reality. U.S. energy consumption of fuel, 2012, oil 36%, gas 27.5%, coal 18%, renewables about 6.5%. By the way, this doesn't differ much from global numbers, about the same. If we break down renewables, about 80% of this 6.5% was ethanol fuel for our vehicles. In 2012, we had 45,000 operating wind turbine towers in the United States. They produced 1.4% of our energy and about 3% of our electricity. And solar was at 0.2% of our energy. Nevertheless, we have a vast array of government policies to promote renewables and to try and stop carbon dioxide emissions. Ethanol mandates for our vehicles. We've banned incandescent light bulbs. The EPA and the Department of Transportation have set up corporate average fuel economy standards, mandates for everyone. Smart meter mandates to go into homes. Subsidies for companies like Solyndra that went bankrupt with $500 million of taxpayer subsidies. And we're in the process of banning coal-fired power plants. The EPA has declared or is proposing that all existing coal-fired power plants either shut down or add expensive carbon capture and storage. The U.S. Department of Energy says that carbon capture and storage adds 70% to the price of electricity, even if we can figure out where to put that underground. By the way, the state of Indiana gets about 80% of your electricity today from coal-fired power plants. Here's an example. Just went into operation about 2 months ago, the California Valley Solar Ranch. It spreads over 1,500 acres, 100 times the area of a gas-fired plant. It produces an output that's 10% of the output of a gas-fired plant. It requires $1.4 billion in federal and state subsidies, and it delivers electricity at 15 to 18 cents per kilowatt hour, 3 times the current California wholesale rate. So 100 times the area, 10% of the output, and 3 times the price. Not a real good bargain for consumers. But all this is driven by the idea that we're going to stop greenhouse gases and global warming. Can EPA policies really affect the climate? Interesting congressional hearing in September of last year. EPA Administrator Gina McCarthy was the witness. Congressman Mike Pompeo said, on your website you have 26 indicators used for tracking climate change. Heat-related death, change in ocean heat, sea level rises, snow cover. And the congressman questioned the Administrator McCarthy for about 5 minutes and basically asked her which of these indicators are going to improve from EPA policies. And she responded, they're indicators of climate change. They are not directly applicable to the performance impacts of any one action. She was basically saying, well, we're going to put these policies into place. We're not going to be able to see any change in any of our indicators. Can we now control the climate? Anyone think we could do that? The mayor of Moscow in 2009 promised that the Russian Air Force could now keep it from snowing in Moscow. And just 5 months later, Moscow was covered in 21 inches of snow, 50% over the annual average. Now, there are many world problems that need solutions. This is a satellite picture of the continent of Africa at night. There's 1 billion people that live on Africa. And as you can see, there aren't many lights on. Many of those people don't have access to electricity. You can compare it to Europe up here or India over here. According to United Nations data, 20,000 people die every day from hunger-related causes. 2 billion people on Earth are trying to live on less than $2 a day. 1.8 billion don't have proper sanitation. 1.4 billion don't have access to electricity. Almost 1 billion people don't have clean water. Millions die every year from disease, AIDS, malaria, diarrheal diseases, and tuberculosis. Yet the world is spending $250 billion a year. We're on track to spend $1 trillion in the next 4 years to try and stop the planet from warming. Wouldn't it be great if we could take that $1 trillion and solve the problems of sanitation, health, education, poverty reduction across the world, instead of a futile fight to try and stop the climate from warming? So in summary, climate change is natural, not man-made. The greenhouse effect is dominated by water vapor, and the human contribution to the greenhouse effect is only 1 part in 100. When you look out your window and you see sunshine, and you see clouds and weather, and if you live near the ocean, you see the power and the effect of the ocean currents. These are the factors that dominate Earth's climate, and that our addition to a trace gas in the atmosphere is very, very small. There is no policy that the Congress can enact that will modify climate change to a measurable extent. There is no regulation that the EPA can put into place that will make the storms less severe. There is no legislation or regulation that the state of Indiana can put into place that will make the droughts or floods either less severe or less frequent. Thousands of climate regulations from hundreds of nations will not make a measurable impact on global temperatures. Thanks, you've been a great audience.
Senator Joe Donnelly was scheduled to speak today, but he couldn't make the trip from Washington because the Senate's in session, and he feels strongly that he should not miss a vote. The bad weather that has been experienced in Indiana has also affected Washington, and much legislation has been delayed due to that, so this was an important week in Washington. However, Senator Donnelly sent in his place Jorge Ortiz, the Senator's regional director in Fort Wayne. Prior to joining then-Congressman Donnelly's staff when he represented Indiana's 2nd Congressional District, Mr. Ortiz attended the University of Notre Dame and graduated with degrees in political science, international affairs, and European and Middle Eastern studies. When Mr. Ortiz first joined Congressman Donnelly's staff, he focused primarily on military and veterans affairs. When Mr. Donnelly was elected to the Senate in 2012, he asked Mr. Ortiz to join him in Indianapolis to continue working in that area in addition to being his liaison to the Latino community across Indiana. Last year, Senator Donnelly asked Mr. Ortiz to take the role of regional director, and in that capacity, Mr. Ortiz represents Senator Donnelly in Northeast and East Central Indiana. Please welcome Mr. Jorge Ortiz.
Thank you, Jim, and thank you to Rotary International and to Manchester University for hosting this conference today. Like Jim said, Senator Donnelly couldn't be here today. He had to be in D.C. for some votes, some very important votes, and he has a 100% voting record in all of his time in Congress, so he's pretty serious about keeping that. So I feel that at this point I should say that I'm not here to advocate in favor of a government-sponsored policies to affect climate change one way or another, so I'm not in favor or against them. I'm here to report simply what that conversation is like in Washington, D.C. at this point. So as you've gathered, the issue of climate change has always been a politically divisive one. The political landscape and compositions of either chamber of Congress at any given point tend to dictate just how far climate change legislation can progress or how strongly opponents can push back on it. In order to understand where the climate change discussion is today and where it is going in the future, I think it's important to understand exactly what climate change is and where the issue has been so far. The United States Environmental Protection Agency defines climate change very broadly as any major changes in temperature, precipitation, and increasingly severe weather patterns that have come about over long periods of time. The one most commonly addressed, and the one you've probably heard of most, is global warming, which is the gradual increase in the planet's temperature. According to the EPA, over the past century, the planet's temperature has risen about 1.4 degrees Fahrenheit and is expected to rise between 2 and 12 degrees over the course of the next 100 years. More and more, people on both sides of the argument agree that the planet's temperature is rising. However, there is no consensus on what is causing this increase. Some point to human activity, beginning with the advent of the Industrial Revolution in the West, while others say that the changes in temperature are consistent with the natural life cycle of the planet. Those who believe human activity is responsible for the rise in the planet's temperature point to global industry releasing greater quantities of greenhouse gases into the atmosphere, resulting in the destabilization of marine and land ecosystems around the world. This warming of the Earth has caused polar ice caps to melt, making ocean levels rise, thereby posing great threats to coastal communities worldwide. Severe droughts and storms and more frequent flooding and heat waves have also battered communities around the world. So now we'll take a look at some of the history where the discussion has been. The issue of climate change first entered the public arena in the 1980s after the first sharp increases in global temperatures were detected. Since then, climate change has occupied a center of vigorous national debate. The first major movement towards national and international legislation to address climate change began with the United Nations Framework Convention on Climate Change, whose first of 3 summits in Brazil brought together over 190 countries as signatories in 1995. The framework meetings culminated in the summit in Kyoto, Japan in 2005, where the agreement entered into force, binding the parties into taking measures to reduce greenhouse gas emissions in their respective countries. It is important to note that the United States is a signatory to this agreement but has not ratified it. The Clinton administration signed on to it. However, the U.S. Senate passed a resolution that would not allow the United States to ratify it if developing nations are not bound by emissions reductions and if ratifying would cause damage to the American economy. Developing nations are not bound to reduce emissions under the agreement in the same way as developed nations, so the United States has not ratified it to date. If we fast forward to 2009, when President Obama took office, he pledged to put in place policies that would reduce greenhouse gas emissions in the United States by 17% below its 2005 levels. He lobbied Congress hard to pass legislation that year that would address this issue. So in In 2009, June of 2009, the House of Representatives narrowly passed the American Clean Energy and Security Act by a vote of 219 to 212. Even though the bill died in the Senate the next year, it is significant because of what it proposed to do in this country. The idea behind the bill was to propose what is called a cap-and-trade system, under which the government sets a limit, or cap, on the total amount of greenhouse gases that can be released nationally, and this cap would be reduced over time to reduce total emissions. Companies would then buy or sell permits to emit these gases. The bill would set a cap on total emission permits to cover the years 2012 to 2050 and would require regulated entities to hold allowances to emit greenhouse gases. After allowances were initially distributed, entities would be free to buy and sell them. This is the trade part of the program. Those companies that emit more gases would face a higher cost, which provides an economic incentive to proactively reduce their emissions. Now, moving back to the international stage, you take a look at the Copenhagen Summit of 2009. This was the 5th meeting of the parties of the Kyoto Protocol, where a document was assembled by the parties recognizing the need to pass measures to keep any global temperature increase below 2 degrees Celsius. Because it was not passed in consensus out of fears from national politicians that their respective national economies would be harmed by economic disadvantages, the agreement never entered into force. For this reason, the summit is viewed by most as a failure. Now, we take a look at the landscape today. In his second inaugural address, President Obama described action on climate change as a moral responsibility for the American people. This past summer, in his Climate Action Plan, he proposed new carbon pollution standards for power plants. In his budget plan this year, he proposed increased funding to study the impacts of climate change. Furthermore, the EPA has recently put forward its new source performance standard, which aims to further regulate carbon dioxide emissions by forbidding the construction of new coal power plants without the adoption of cleaner burning technologies. This proposal has raised great opposition from a bipartisan group of lawmakers who come from coal states such as Indiana, Kentucky, and West Virginia, who claim that such technology has not been tried and tested on a commercial scale and would have negative impacts on the local economies of different states. On the other side of the coin, earlier this month, the House of Representatives passed a bill that would greatly curb the EPA's ability to regulate such carbon emissions. Despite passing in the House, the bill holds little chance of passing in the Senate, with President Obama already threatening a veto should it arrive on his desk. On the Senate side, members of the United States Senate staged an all-night talkathon earlier this week to bring greater awareness to the issue of climate change. 30 Democratic senators who are members of the Senate Climate Action Task Force spoke about the dangers of climate change and of the need to act on it now. And now we'll take just a brief glimpse into the future. Though the progression of action on climate change in this country is uncertain, such progression in other countries is more steady. Much of the work in introducing climate change laws internationally has happened in emerging markets such as China and Mexico. This is significant because these were once countries that had been reluctant to sign up, thinking that carbon emission limits were rich, industrialized countries' attempts to discourage the use of fossil fuels in their own developing markets. China, for instance, has introduced 7 pilot carbon markets with plans to introduce a nationwide carbon market by 2015. In the past several years, almost 500 climate laws have passed. 8 countries passed climate laws in 2013, with another 19 countries taking positive steps along the same route. This progression is a positive sign for climate change advocates in the lead up to the Climate Change Summit to take place in Paris in 2015, where many people hope a global agreement on climate change policies will be signed. As you've probably guessed, we've only scraped the surface of this topic, but I hope that you did find this overview of what is going on in the United States Congress to be helpful. I hope that the rest of the conference will provide you with more information so that you, as the future leaders of this country, can determine what is the right policy that this country should be heading towards with regards to climate change. So again, on behalf of Senator Donnelly, I'd like to thank Rotary International and Manchester University for putting on this forum, and we wish you well for the rest of the conference. Thank you.